Dive into the world of infrastructure as code with this hands-on course by Rishab Kumar, who will guide you through the essentials of deploying a website on Google Cloud Platform using Terraform. Through this course, you'll gain hands-on experience deploying a fully functional website on Google Cloud Platform. You'll learn to write Terraform code, manage cloud resources, and handle custom domain configurations, all while understanding the principles of effective and efficient infrastructure management. By the end of this course, you'll be well equipped with the knowledge and skills to leverage Terraform in creating and managing scalable and automated infrastructures on the cloud. So, let's begin.
Today, I'll talk about the famous infrastructure as code tool known as Terraform, and will deploy a website to GCP, which is the Google Cloud Platform. And if you are not familiar with infrastructure as code, it is one of the important DevOps principle which allows you to deploy your infrastructure to any of the cloud providers using a code file, which makes automation easy. So let's dive into what we'll be needing today. So for the requirements, first of all, you need a GCP account, which would allow you to deploy resources to the Google Cloud Platform. You'll also need Terraform installed on your dev machine. And since we'll be deploying a website, you need a domain name that we can point our website to. And at last, we also need the gcloud CLI installed and authenticated on our dev machine. Going over the architecture diagram, this is what we'll deploy today. So if any of the users try to visit our website, Cloud DNS, which is a GCP service, will handle that request of whatever our domain name is. It'll go to the CDN, which is again a GCP service known as Content Distribution Network. And then we'll be using a cloud load balancer to forward those requests to cloud storage, where we will have a bucket containing our website content. So this is the architecture diagram, gives you kind of an overview of all the resources that we'll be needing today in GCP to deploy our website. So before we start with any Terraform code, I want to make sure you have your Google Cloud account set up. So if you haven't created an account, you'll need an account with active billing, even though the costs for this project will be minimal since we are using Google Cloud Storage to store our website content. Couple of cents for that per month, but you can incur charges for your load balancers as we saw in the architecture diagram. That being said, you still get some credits. You also get a free tier from Google Cloud. So for your Google account, what you want to do is, in order to manage the resources efficiently, you have projects in Google Cloud. So you can go ahead and create a new project after you have created your account for you to deploy the infrastructure. So I have created a YouTube project here, as you can see, and have selected that. Google Cloud gives a random project ID, or you can choose your own project ID. And I have selected that as my project for today's course. Now, there are a few APIs that you have to make sure are enabled. So you need Cloud DNS API, since we'll be using a domain name. You also need Compute Engine API, since we'll be using the load balancer. And you also need IAM API, and I'll tell you why. In order to enable these APIs, on your home page of the project, you can see there's quick access menu and you have API and services. If you click on that, you'll be able to enable different APIs and services. So you can search for Cloud DNS API. And as you can see, shows up the Cloud DNS API. On my project, it's already enabled, but if you don't have it enabled, here will be a button saying enable this API. Similarly, if we search for Compute Engine API for our load balancer, we can enable that too. And then last but not the least is IAM API. So make sure all these APIs are enabled, and we need these in order to proceed with our project today. So after we have done that, what I'll do is create a service account for Terraform to authenticate to Google Cloud. Since we'll be using Terraform to deploy our infrastructure for our website, it needs a way to authenticate to Google Cloud to deploy that infrastructure. And the way it does that is through a service account. There's a documentation available from Google Cloud on how to create a service account, and I'll make sure it's linked down in the resources below. But I'll just show you how you can create one. So if we go to service account, which is available in IAM and admin, and if you go to service accounts, you'll see that I have two service accounts here. Let's click on create a service account. And now you can name this accordingly. So let's name it freeCodeCamp.org. And then Google Cloud will also assign it a service account ID. And you can put in the description saying Terraform GCP. And then you can click on create and continue, where it'll ask which role you want to assign. So I highly suggest you fine-grain the access that you provide this service account. Since I showed in the architecture diagram that we'll be using Cloud DNS, CDN, load balancing, and cloud storage, you can limit the access for this service account only for those services by searching for those services here. But for the purposes of this demo, I'm just gonna go with basic and click owner. But you can see there is a message saying full access to most Google Cloud resources. See the list of included permissions. If by mistake you expose your service key, which will generate and store today for our Terraform project, if you expose it publicly, you have the risk of individuals having access to your entire Google Cloud account. So make sure you have fine-grained your access to this service account, but I'll choose owner for the purposes of this demo. So I have given the owner access, and now we can click on done, and you can see it generated a service account called freeCodeCamp-Terraform. So now we'll need an API key for this service account. And how you can do that is by clicking on keys, click on add key, create new key, and let's go with the JSON format. It's also the recommended format by Google Cloud. If you click on create, what it'll do is ask you to save the key locally on your machine. Let's do that. And then once we get to the Terraform part of this, where Terraform needs to authenticate and deploy infrastructure to GCP, I'll show you how you can use this API key. But yeah, this was how you can create a service account, and we also created the Terraform project inside GCP, and we needed to enable Cloud DNS, Compute Engine, and IAM API. Now let's go with second requirement, that was installing Terraform. So I'm on the official Terraform website from HashiCorp, and installing Terraform on Mac OS is pretty easy. You can just use homebrew by typing the command brew tap HashiCorp tap and then brew install HashiCorp/tap/Terraform. So let's go ahead and do that. Let's copy the first command and go to our terminal, paste it, and let's copy the second command, which will install Terraform. And there we go. So I already had Terraform 1.4.6 installed, which is up to date. So that's why you're seeing that message. But in your case, if you don't have Terraform installed, Brew will go ahead and install it for you. So now let's start writing some code. What I'm going to do is go to the right directory on my dev machine here, and then create a new directory called Terraform with GCP. And let's open that up in VS Code. Okay, So I have the directory open here in VS Code, and as you can see, it's an empty directory. So let's start with creating a folder for our infrastructure, and let's name it infra. I'll start with the fundamental Terraform file that we need, which is usually named as main.tf. And this is where most of our Terraform code will go, but we also need to pull the provider GCP from Terraform's registry, and I'll show you how you will do that. And the best practice is to have it not in main.tf, but another file called provider.tf. So let's do that right now as we are starting. So provider.tf, and we'll bring the GCP provider in this Terraform file. So let's start writing some HCL. So I'm just going to make a comment here saying GCP provider on the top. And then what we are going to do is pull that provider from the Terraform registry. So provider, and then we'll go with Google as our provider. And we also need to specify some config for this provider. First of it is the credentials. So this is where our service account, which we created before, will come in, which will allow us to authenticate to GCP. And a project. So what project should the infrastructure be deployed in? And as you can see, I'm using var here, which stands for variable, which basically means it allows us to assign variable values and not hard code it into the provider column here. So let's go with GCP under project, and you can name your variables accordingly. And last one is region, which for me, the nearest one is US East 1, but we'll define that in the variable files that you'll see later. And there we go. So we have our GCP provider pulling in into provider.tf. Let's go back to main.tf and let's start with creating a cloud storage bucket where all of our website code will exist. So let's start with a comment saying bucket to store website. And then let's create a resource. And you can do that by typing resource. And let's go with storage _ bucket. And let's call it website since we'll be using it as a website hosting. So there we go. We created a resource called bucket, and then provider. You can specify that if you're using multiple providers in your provider.tf file, or you can leave it if you only have one provider, which is in our case. So let's go ahead and delete it. So now let's name our bucket. And again, you can use a variable here, but I'll just go and name it example website by Rishab. That's a long name. I feel like it'll be unique. Make sure you choose a bucket name that's unique because they need to be globally unique as per the instructions by GCP. And then location is US for our bucket. So we have just created our first resource in the Terraform file. Mind you, it hasn't been deployed yet, and you'll see how you can do that later. But let's go ahead and we'll need an index.html file that will upload to this bucket. And I'm gonna cheat here a little bit. I already have index.html that contains my social links like Twitter, GitHub, LinkedIn, Instagram, and I can show you locally here, but I'm gonna use that and upload it to this bucket. So let's create a folder here in our root directory called website. And in that website directory, I'll have an index.html. And this will serve as our code for the website. Okay, so this is the index.html I was talking about. I can show you locally here how it looks like, how the website is. So I have a local server running. And if I go to localhost port 5500, you'll see the website. So this is the website that I was talking about. Nothing fancy, simple index.html with some social links for myself. And remember, if you're using GCP Cloud Storage bucket to host your website, it needs to be static. It can have JavaScript and CSS, but you can't host a dynamic website on cloud storage. So there we go. We have a simple website that will deploy to GCP using Terraform. And now let's come back to our Terraform file and upload this index.html from local storage to our bucket. And how you do that is by creating a resource for object. So items in a bucket are known as objects. So let's do that. I'll create a comment saying upload the HTML file to the bucket. And let's create that resource. So resource, and then we'll be using Google Storage Bucket object. And we'll name it static underscore site underscore source. And now let's name the object itself. So this name represents what the object will be called in the bucket and not locally. And now we can define the source where this object is being uploaded from. So in our case, it's the root directory and then website and then index.html. And you also have to specify which bucket you want to upload this to. And I'll show you how you can use, in order to use our website bucket that we created on top, we can just go ahead and do .website.name so that we don't have to hard code it. I'll just grab whatever the bucket name is, which is example-website-by-reshub. This helps because if you used a variable here and you created a different bucket name, your code will not be broken if you're hard coding it here. So that's how you do that in Terraform. And one key thing to remember is since we'll be hosting a website, our objects in the bucket need to be public. So let's go ahead and do that by defining an object access control. So let's do that before we upload the object. So make new objects public. And since I won't be using this bucket for anything else, I'm fine with having my index.html publicly accessible, but make sure you know what you're doing. Don't upload sensitive information to a public bucket. So resource, and then this time we are creating an object access control. So Google Storage Object Access Control. And we'll name this public underscore rule. So by now you might have realized that first we have the resource which the Terraform will call to the provider's API. So this is all defined by the GCP provider. How to create a storage bucket, how to create a storage object. So all of this naming convention is predefined by the GCP provider, and you can read about it in the GCP provider documentation available on Terraform's website. Whereas the second part of the resource syntax is the name that you're giving to this resource in the Terraform file. So this is not the name that will be on GCP, but it's the name that Terraform knows it as. And then GCP itself will have this bucket name that we defined for that resource. So just trying to explain the syntax of Terraform. So now we are creating the object access control. Let's go ahead and define our object here. So again, we'll be using the index.html name, but we can do is Google Storage underscore bucket underscore object dot static site source and dot name, so that we are not hard coding the name. And then same thing for our bucket. website.name. So now you can kind of relate why this name here in the double quotes is a reference in Terraform, but not the actual name of the bucket, because we can repurpose it in different blocks later when we are creating resources that are dependent on the initial resource. We'll give the role through this ACL as reader, and the entity, which can be a user, a single user, a group. In our case, I want it to be public, so all users. And there we go. So far, we have created 3 resources in our main.tf. One of them is the storage bucket, where we'll store our website contents. The next one is a storage object access control, which allows the objects in the bucket to be public, since we want people on the internet to be able to access our website. And then the third resource in our main.tf is uploading the index.html file from our website directory to the GCP Cloud Storage bucket. So remember, I showed you how to create a service account and an API key in GCP for our Terraform project to be able to authenticate. We will use that key now. So what I want you to do is copy that key that you downloaded then to your project directory right now. So I'm gonna do that as well. So in my root of the project directory, I'm just gonna paste the key. And as you can see, the JSON key that I downloaded is now in the root of my project. Now we will use this key to authenticate Terraform to GCP to deploy resources. And that's where you can see how, we had this segment in our provider.tf where it says credentials, use file, and then we are referring to a variable called .gcp_service_key. So let's create variables.tf in our infra folder. And here we will declare the variables we need to have for our project, which we haven't done yet, even though we were specifying it in the provider.tf. So let's go ahead and do that. The first variable is GCP service key. So GCP_service_key. And I'm going to leave the other arguments blank for now. The next variable is GCP project. And the last one is GCP region. And again, I'm going to leave the arguments for these variables blank for now. So let's save that. And there are multiple ways you can assign these variables the values. So you can either do it during running the Terraform CLI command, or you can provide with the tf-vars file. So let's go ahead and create that too. Let's name it terraform.tf-vars. So for an example, let's say you wanted to deploy this to a dev environment in your GCP and you had a different project. So you will specify the details of the dev environment in this terraform.tf-vars. And similarly, you will have a different tf-vars file for a production environment, which you can call prod.tf-vars. And that would have, project ID of production environment, region of production environment, and a service key that allows access to the production project instead of the dev ones. So you can see how you can use the .tf-vars file in, different cases. So in our case, since we only have one environment, let's go ahead and assign those variables value. So the GCP service key is the first one, which allows us to authenticate Terraform to GCP so that it can deploy infrastructure. And I'm going to copy the name of my service key here and paste it. So now I have my service key. Next variable was GCP project, and it's Lateral Academy 314813. And you can find your project ID in the GCP console, which we created in the beginning of this course. So if you go to your console in browser And if you click on projects, remember I created YouTube, and you can get the ID of that project from this screen. So going back to TFVAR files, let's go with GCP region, which is the last variable. I'm closest to US East, so I'm gonna use US East today to deploy my website. So there we go. We have assigned the variables that we defined in variables.tf some values according to our need. And I'll save that file, and let's go back to main.tf. And now let's deploy the bucket and see if our Terraform code works. So right now what I'm doing is, since we have the code for cloud storage all figured out in Terraform, let's try deploying this and see if we have an object called index.html in our bucket in a cloud storage. So what I'm gonna do is open up the terminal. Let's clear the screen. And now let's go to the directory of my project, which is called Terraform with GCP. And now let's change the directory to infra because that's where our Terraform files are. And now in order to initiate the Terraform project, you have to do Terraform init. So this will generate some boilerplate files that are needed, like the state file, and I'll explain what it does. So let's do Terraform init. It will also go and check the provider that we are using. So in our case, we are using HashiCorp's Google provider from their registry, and you can see it's installing that provider. And we can also see that Terraform has been successfully initiated. So if I go back to my code editor, we'll see a bunch of files that were created and a directory called .terraform was created. This is where the state files will exist. And what I mean by state is, once we deploy our bucket now, let's say we want to destroy it or we change something in our main.tf, it'll remember the infrastructure state the last time we did a Terraform apply. So let's say we add load balancer and we add Cloud CDN and Cloud DNS. It will not create the bucket again because it already had done that. And you'll see this once we do Terraform apply. Since it can remember the state of the infrastructure, it'll not deploy the bucket again, but would just deploy the changes, which is adding Cloud DNS, Cloud CDN, and load balancer. So that's what all these files are. Let's go back to our terminal and do Terraform plan. So Terraform plan basically tells you what all resources would be deployed. So it won't actually deploy the infrastructure, but just give you an idea of what all resources will be deployed to GCP in our case. So you can see there's the bucket, there's the index.html, and then there is the object access control public rule that we created. So the plan says 3 to add, 0 to change, and 0 to destroy. So this is what I meant by state. Now let's do Terraform apply. Yes. So it went ahead and added all those 3 resources. Now, if we go back to my Google Cloud Console and we navigate to cloud storage, we should see a bucket named example website. So search for cloud storage and you can see we have an example website by Rishabh that was just created. So let's click on that. It has an object called index.html, which is, according to the public access, it is public to the internet. So let's open that. It has a public URL. Let's try to visit that. And there we go. That was the website we had locally, right? So this is localhost port 5500 that I showed you in the beginning, the index.html that I created. And this is on the Google Cloud Storage. So our site is basically live, but we are still accessing the object directly from the storage. What I would like to have is a load balancer in front and Cloud CDN, which will help us with caching the content of our website, and a DNS which would give our site a more friendly domain name. So yeah, we have been successful in deploying the 3 resources we defined in our main.tf. Now let's move forward with the load balancer, CDN, and DNS. So let's go ahead with the next part of our architecture, which will be using the load balancer. And one thing with load balancer is that you will be given an IP address, and I want to make sure that IP address is static, not dynamic. So what I'll do is reserve an external IP before I create the load balancer. So let's go ahead and do that. So I'm gonna make a comment saying reserve a static external IP address. And then what I'll do is create that resource. So resource, and the way you create an external IP is Google _ compute _ global _ address. And then we'll call this website _ IP. So the name can be, and this is the name that will go in GCP. So website, let's put LB, which stands for load balancer, and then IP, and we are good. So that gives us an IP that will be reserved for us that we'll use later in our load balancer. Also, so the way I have set up my DNS zone, I'll show you in GCP. So since we are talking about IP address for our load balancer, let's also go over how we will configure the domain name. So what you have to do in order to configure the domain name is you have to first enable the Cloud DNS service. You can already see that I have a zone name, reshab-example, and it has a DNS name, gcp.reshab.cloud. So you could have any domain name service provider like Namecheap or Google Domains or Route 53. But what you will have to do is either transfer that domain name to Cloud DNS, or you can create a zone for a subdomain. So let's say I want to create a zone for this project called Terraform-GCP. The DNS name that I own is reshab.cloud. So I'll create a subdomain here called test.reshab.cloud. And then for the other settings, you can leave it default and click on create. So what it'll give you is a list of name servers. And if you click on the NS record, you can see those 4 name servers that the Cloud DNS for GCP uses. And what you will have to do is go into your domain name service provider, so Namecheap or Route 53, and create this record with the DNS name test.reshab.cloud and the type being name servers, which is NS, and paste all these 4 values in there. The DNS propagation can take some time, and that's why I already have the example zone set up that I'll be using in this project, which points to gcp.reshab.cloud. So since I already have the DNS zone created, what I want to do here is not to create it, but get the managed zone. So get the managed DNS zone, and how you can do that is through data. So data Google DNS managed zone, and then what the name of that zone will be in this Terraform file. So let's name that DNS zone. Pretty straightforward. And now we will get that data from the GCP provider. So in my case, the DNS zone was named reshab-example. So just to clarify, we are not creating the zone. We are getting it from the Google Cloud provider since it already exists. So now let's add that IP address that we reserved to this DNS zone. So add the IP to the DNS so that the name translation happens fine. So if you go to website.gcp.reshab.cloud, it translates to whatever the reserved IP points to the load balancer. And let's name this website. So the name that I want is website but then I want to use whatever the DNS zone got us. So you can use $sign and then curly brackets. And you already see the Terraform extensions that I have installed is auto-populating that DNS zone name. So let's go ahead and type it out instead. So data, and then I can copy this manage DNS zone record. It's called DNS zone. And at last, its DNS name. So there we go. The new record that will be created for our reserved IP would be something like website.gcp.reshab.cloud. And I could have put in anything in front here. It would be xyz.gcp.reshab.cloud. So I hope you understand what I'm trying to do here. The type, since it is an IP address, will be A and not a CNAME. And then TTL, which is time to live. Let's go with 300 seconds, which is 5 minutes. The managed zone that we will be using, again, we don't need to hard code it. We can just use the zone that we got from GCP earlier. And at the end, we'll not need DNS name, but just the name, which is reshab-example. So instead of hard coding this here, I just am relying on Terraform to figure it out itself. Now we have the RR datas, which is the string data for the records. In our case, since it's an A-type record, will be the reserved IP address for the load balancer. Moving along, let's add the bucket as a CDN backup. Remember, we are using a cloud load balancer, which will need a backend to serve the content, which is our bucket. So the resource before the load balancer that we are creating is that backend. So Google Compute Backend Bucket, and let's call it website-backend, and let's also name it website backend. And then for the bucket name, we have the Google Storage bucket.website.name, which it will pull up from here. So this is the bucket name that it'll get. Let's also add a description to the backend. So contains files needed for the website. And this is where you also enable CDN. So enable CDN is equal to true. So this will enable Cloud CDN for us for our backend bucket. So we created the backend bucket. Now let's create a URL map. So this is a property in the load balancer, which allows us to specify when a user enters a specific URL path that is being served by the load balancer, what it should direct the traffic to. In our case, it will be the backend bucket that we just created. So let's go ahead and do that. So resource Google_compute URL map, and let's name it website. The name can be website-url-map. The default service that it's going to use is the backend bucket that we build here. So you can get the name of that backend is by doing Google_compute_bucket.website-backend.self_link. And now we have to also specify the host rules. So host_rule, and this is where you can tell like where the traffic should be pointed to depending on what host the user is asking for. So let's say you hosted in this bucket, you had images and videos, and you wanted the load balancer to manage the traffic based on the type of content that is being asked for. So you would have something like /images as the path for images, and then /videos for the video content. And this property lets you define those rules. So for hosts, I'm gonna go with anything needs to be in double quotes. And you also need a path matcher. So path matcher for all paths. And then we also have to define that path matcher. So path matcher name is equal to all paths. And default service is our backend website. So So the backend that we created with CDN enabled, we need that. So it will be .website-backend.self_link. So this is where all the paths will lead to, which is what I want because we don't have anything specific being hosted on a different path. I just want everyone who accesses xyz.reshub.cloud to go to the index.html that is being served by this backend. So there we go. We have our URL map set up. Now let's create our load balancer. So the resource that we want now is the Google Compute Target HTTP proxy. And let's name it website again. And you can name the resources accordingly as you like, or if there is a specific naming convention that you follow. So let's go ahead and for the actual name in GCP, let's call it website target proxy. And then the URL map that we created, we want to use that for this target proxy. So it'll be Google_compute_URL_map.website. Yep, so we named it website within Terraform. So website.self_link. So that is the URL map we want to use. And now we can go ahead with creating the forwarding rule for our load balancer. So let's make a comment saying GCP forwarding rule. And then let's create that resource. Okay, so we have the Google Compute Global Forwarding Rule, and let's name it default in Terraform. For the name in GCP, let's call it Website Forwarding Rule. Load balancing scheme is gonna be external, since we need an external load balancer that listens to internet requests. IP address, and this is where we will use the IP address that we blocked on the top. Remember, we had a resource that would reserve a static external IP address for us. So we will use that here. So we can refer to it in Terraform by doing Google Compute _global _address .website _IP .address. So this will link that reserved IP to our load balancer. And then the IP protocol we have to define is TCP. So listen to that. Port range. So in terms of best practices, you should be using port 443 here. And you'll need an additional resource in order to do that is the SSL certificate, which you can get from GCP. And I can show you the code bit that's required to get the SSL certificate. But the SSL certificate creation process can take some time, and hence, for the purposes of this demo, I will not be including the SSL certificate resource itself. So that's why I'm using port 80 so that we have a working website that is being served by a load balancer on our custom domain. And target, as you can guess, will be our proxy website that we created here. So Google Compute Target HTTP proxy .website.self_link. So we have all the resources that are necessary according to the architecture diagram we had. So we have the cloud storage account that we already deployed, and we saw we could access the index.html. We have the load balancer now. We have a backend that is being served by the load balancer, which has CDN enabled, and we have the DNS that we configured in our main.tf. So let's save our main.tf, go to our terminal here and do Terraform plan. We'll see that it plans on adding 5 resources instead of 8 or 9 because we already deployed the bucket and we also uploaded the index.html in the previous Terraform apply. So this is where the state comes in. State remembers what all infrastructure has already been deployed from our Terraform code, and it will not redeploy that again. Or if we changed the index.html to something else, it'll have detected that change and would have said want to change. So that's the concept of Terraform state file. Let's go ahead and do Terraform apply to deploy our changes to Google Cloud. It'll ask you to enter yes if you are willing to deploy these changes. Let's go ahead and do that and wait for these changes to be deployed. Okay, so we have the apply complete. We have added 5 resources. Now we can go to our GCP account and look for those resources. So the first thing I would love to check is the load balancer. So let's go to load balancer. There we go. So you can see it did create a website -URL-map, which is a classic HTTP load balancer and has a backend bucket. Let's go ahead and look at it. So this was the IP address that was reserved for us. The backend bucket is the example website by Wcislo, which we wanted, and the Cloud CDN is enabled. So basically we have deployed all of the parts of this architecture diagram. Now what we have to do is see if we can access our website by going to this IP /index.html. So I'm going to paste that in the URL bar here. And there we go. We have our website that I wanted to be deployed to GCP being served by the load balancer. The next thing to test would be the domain name. So if we go back to Terraform file and look at our DNS record set, it's website dot and then whatever the domain name I had in GCP, which is gcp.wcislo.cloud. And I can show you here because we should see in Cloud DNS, we should see a new record. So if I open that up, we have website.gcp.wcislo.cloud, and it is pointing to the IP address of the load balancer that we just visited. So now Terraform did its part where it created that DNS record and pointed it to the load balancer IP. Let's just test it out. So website.gcp.wcislo.cloud/index.html, and there we go. We have our website being served on a custom domain with a load balancer and the Cloud CDN and cloud storage as the bucket for our project. So that was the project today. We deployed all the resources necessary using Terraform to GCP. The one bit that I want to cover as we're towards the end is the HTTPS or SSL certificate if you want to create the external load balancer that's on port 443, which is the recommended practice. So all of the code for this project is available on GitHub if you ran into some issue. And I'll link the GitHub repo in the description below. But this is how you can get the HTTPS certificate. So you have to create a resource called Google Compute Managed SSL Certificate and the domain name for that, which you can use the previous resource we created, which was website.gcp.wcislo.cloud. So I have gone ahead and did that, but it still needs some time for the SSL cert to be provisioned. But you can see it is getting an SSL certificate for website.gcp.wcislo.cloud, by which my load balancer would be able to serve traffic over port 443. So the code will be available on GitHub, but that's the way to get an SSL certificate. And if you want to clean up your resources, you can do that by doing Terraform Destroy, which will delete all the resources that we just added. So not only the 5 resources, but also the bucket that we added in the beginning. So you can see the total resources to be destroyed are 9. So you can do that and clean up your environment. This also depends on the state. So that's how it knows that it needs to delete 9 resources. But yeah, Terraform Destroy is the command to clean up those resources. So yeah, the important commands for Terraform are Terraform init, which initializes your project, Terraform plan, which will tell you what it plans on deploying, Terraform apply, which needs a yes argument for it to deploy the infrastructure to your cloud provider, and then Terraform destroy, which also need a yes argument to destroy all the infrastructure as it is happening right now. So all of our 9 resources have been destroyed. One last thing before you all go, wanted to mention is if you plan on hosting your code on GitHub, make sure you have added a gitignore to the root of your project, and you have added the service key to not be pushed to a public GitHub repository, because it's important. It's your API key that gives you access to your Google Cloud account. So the template for the gitignore includes some Terraform state files too, and can be found on the same GitHub repository that I've shared in the description. So you can copy that for your own gitignore, but make sure you have added the service key to the bottom of the gitignore. So that was the project we built today. We learned about Terraform, which is an infrastructure as code tool, also a great principle in the DevOps, helps you automate all infrastructure things. And we also learned how you can host a website in GCP by using load balancer, cloud storage, and also how to have a custom domain pointed to it. I hope this project helped you understand these concepts, and I can't wait to see what you build.